We're going to calculate the values of these three definite integrals using the Fundamental Theorem of Calculus. The Fundamental Theorem of Calculus says to calculate the value of a definite integral of f of x from a to b, we first find an antiderivative, and then we plug in the endpoints of integration and take the difference. The integral from a to b of f of x dx is capital F of b minus capital F of a, where capital F is an antiderivative of f, meaning that capital F prime is f. So we need to find an antiderivative in our first example here of t squared minus 5t plus 2. An antiderivative using the power rule here is t cubed over 3, and then minus 5, power rule again, t squared over 2, and then plus 2t, just because the derivative of 2t is 2t. Our variable is t here, so we wouldn't want to say 2x there. And we have 2 on the top and 0 on the bottom. If we plug in 2, then we get 2 cubed, which is 8, divided by 3, minus 5 times t squared over 2. So 2 squared is 4, times 5 is 20, divided by 2 is 10, and then plus 2 times 2 is 4, and then some arithmetic. This is 8/3 minus 6, and 6 is 18/3, and so this is negative 10/3. For the second one, integral 0 to pi of 3 cosine theta minus 4 sine theta d theta. We need an antiderivative. The antiderivative of cosine is sine. So this is 3 sine theta. And then the antiderivative of sine is negative cosine. So this is going to be plus 4 cosine theta. And whenever you're doing an antiderivative with sines and cosines, we should double check, because we've probably memorized the derivatives of sine and cosine pretty well. The derivative of sine is cosine, and the derivative of cosine is negative sine. And we can just verify then that the derivative of this function here is indeed this one. And then we have to plug in pi and 0. So we get 3 times the sine of pi plus 4 times the cosine of pi minus 3 times the sine of 0 plus 4 times the cosine of 0. And then on the unit circle, our angles are 0 and pi. Pi is 180 degrees. The coordinates of this point at 0, theta equals 0 radians, is 1, 0. And when theta is pi radians, this point on the unit circle is negative 1, 0. The sine is the y coordinate. So the sine of pi is 0, and the sine of 0 is 0. So the sine of pi is 0, and the sine of 0 is 0. The cosine of pi is the x coordinate. That's negative 1 times 4 is negative 4. And then minus, I wrote a plus sign there, minus there, 4 times the cosine of 0. The cosine of 0 is this x coordinate, which is 1. So 4 times 1 is 4. And so we get negative 4 minus 4, which is negative 8. And finally, for the third one, we want the integral from 0 to 1 of 2 to the x dx. So we need an antiderivative for 2 to the x. Let's recall that the derivative of 2 to the x is 2 to the x times the natural log of 2. Now the natural log of 2 is just a constant. So we want to look for a function whose derivative is just 2 to the x. So we will move this constant to the other side of the equation. So 1 over the natural log of 2 times the derivative of 2 to the x is equal to 2 to the x. And then since this is a constant, we can use the constant multiple rule and put the constant in there so that the derivative of 1 over the natural log of 2 times 2 to the x, the derivative of that will be simply 2 to the x. So this is our antiderivative. 1 over the natural log of 2 times 2 to the x. And we have to plug in the numbers. So we get 2 to the 1, which is 2, divided by natural log of 2, minus 2 to the 0, which is 1, divided by the natural log of 2. And so this is 2 over log 2 minus 1 over log 2. They have the same denominator, so we can subtract in the numerator, and we get 1 over the natural log of 2.